A local arena has 10 applicants interested in working in snack bar. How many ways can 4 applicants be chosen? So sometimes we see this word chosen. It's a word more often used with combinations. But the first thing we always have to ask, because on your exam, permutations and combinations questions will be mixed together. First question you're going to ask, does the order matter? If the answer to that is yes, you go to your permutation strategies. If the answer is no, you go to your combination strategies. Does it matter the order that they hire 4 applicants? No. They're going to hire 4 of them anyways. Doesn't matter if you get hired first, second, third, or fourth. If they were hiring for 4 different jobs, right? One of them was cleaning up. One of them was working at the front desk. One of them's a manager. They're making different amounts of money, and the job satisfaction is different for each of them. Then order matters. Then you will do your spaces, and you would go 10, 9, 8, 7. But since the order doesn't matter, this is a combination. You just have to do 10, choose 4. You go right away to your formula. 10 factorial will be on the top, 4 factorial will be on the bottom. And then on the bottom 2 numbers always add up to the top number. So go to your calculator. This is quicker. You'll get 210 ways in total. And then in part B, they say, how many ways could you, all of a sudden you're like, no, we can't just hire 4 people, that's not enough, we have to hire 6. So now you're doing 10, choose 6. And this is an important property of combinations. If you type this into your calculator, you also get 210. Does it make sense that these are the same? Well, with the formula, the first formula you had a 10 factorial on the top, a 4 factorial on the bottom, and then you figured out what would add up to 10. So you added the 6. This one's going to have a 10 factorial on the top, a 6 factorial on the bottom, and what's going to add up to 10? A 4. And you see that that makes the bottom identical, just in a different order. And multiplying doesn't matter the order, so you're going to get 210 the same way. If you take a deck of cards, there's 52 cards in the deck. And I would like you to choose 51 of them. That's going to take you some time, right? But you're going to end up with 51 cards in the end. And then I'll give them back to you, and I'd say, I'd like you to choose a different 51. Okay, so you do it again, choose a different 51. Then I say, I'd like you to do that again. How many times can you choose 51 cards different? Okay? Well, 52 choose 51, there's 51 of them, is the same as 52 choose 1. That's a much easier question for your head to figure out. 52, choose 1 card. How many different ways could you do that? 52 different ways. So if there's 52 different ways of choosing 1 card, there's 52 different ways of choosing 51 cards. With the formula, 52 choose 50, well, let's start with 50, just choose 1. 52 choose 1 would be 52 factorial over 1 factorial, 51 factorial. This you could do mental math. How do we simplify factorials? We start with the bigger one, which is the 52. We go down by 1 until we get to the one that's on the bottom. Wow. Those would cancel out. And you're just left with 52. 52 choose 51. Is exactly the same thing. So this idea comes up a fair bit on questions on the exam. Sometimes they have questions like this. If I have 12 choose 9 equals 12 choose x, and x doesn't equal 9, What's X? And you don't have to show any work for this. It has to be 3. Because if you make a group of 9, you leave a group of 3. So another thing with combinations you can think about making groups of things where the order doesn't matter, right? Like say tomorrow we're going to have a take-home quiz and I'm going to put you in groups of 3, okay? So Mahad, I'm going to put you with Abdul and Andre. And you're like, no, I want a new group. I'd like to be with Andre and Abdul. You'd be like, Mahad, it's the same group. Right? Just because you chose them in a different order doesn't make your group different. Right? So when we have choosing groups of 3, the order doesn't matter. So then it will become a combinations question. Okay. Example number 2, you can circle questions 8 and 10.